Diodes like for example these 1N4140X are main building blocks of modern electronic circuits. They are often used as rectifiers, allowing current to flow only to one direction, from anode to cathode. Another feature is voltage drop, which is depending on diode somewhere around 500 millivolts. Most applications of diodes are based on one or both of these features. The voltage drop will change based on current, but even at the constant current the temperature will change that. Change of the voltage drop will be quite linear based on the change of the temperature. It's about -2 mV per 1 degree Celsius. Knowing that, it's quite easy to use a diode as a temperature sensor. First thing is to apply a constant current through the diode, then measure voltage at two known temperatures, then divide the voltage difference by the temperature difference to get the actual millivolt per Celsius change. Then simple math can be used to get the actual temperature from voltage reading by using one known temperature point from step 2 and the calculated value from step 3. Then repeat as many times as needed. For demonstration I'm using P-shock force internal constant current source and the 12-bit ADC. I have also connected a LCD to show the calculated temperature values I'm getting from this diode, which is connected between ground and the output of the constant current source and the input of the ADC. Instead of doing the whole calibration process, I guessed the room temperature and I'm using the -2 mV per 1 Celsius degree to calculate the temperature change from the first ADC reading, which was done when the diode was at the room temperature. These non-calibrated values are quite good, but doing the simple calibration would make them even better.